Hi everyone, welcome back to this channel. It's Edmond here. This is a walkthrough of 2025 S1 summer series. I'll explain the concepts and see how we reach to the right answer. Thank you. We are moving on to question 5. All right, question 5. Question 5 says that we have a frequency distribution table here that summarizes the speed in kilometers of randomly selected 225 cars on the road. So we have a table over here. So 2025, there are 54, and so on. The first question, they have told us that an histogram was drawn, and the height of the tallest bar is 10 centimeters. Calculate the height of the second tallest bar. Now, when you're drawing the histogram, you remember that we are going to draw it using frequency density. It is frequency density. Again, it's the class sizes. In this case, going to be again is the speed in the kilometers per hour. So that means the frequency density, the height of this tallest bar is 10 centimeters. That means you have to identify which one is the tallest. So we can only do that by getting the frequency density. So you can make a column over here with the frequency density. Remember, frequency density is going to be the frequency over the class size or the class width. So the frequency density we have here, we're going to have 54. That's the frequency divided by 5. Right, and then we have this going to be 10.8. Then we have the next one. We have 90 divided by the size over here, which is 5, which is going to be 18. And then you have 60 divided by 10, that will be 6. And you have 15 divided by 15 here, which is 1. And 6 divided by the side, the class size over here, which is 15. I don't need the answer here. I already got the biggest one. So the tallest one here is the 18. The tallest one is 18. That means the second tallest is 10.8. 10.8, second tallest. Now let us answer the question. That means when the histogram was drawn, this is our histogram drawn over here. The height of this bar, which is 18, the frequency density is 54, the height is 18. This 18 was represented by 10 centimeters. Now we are looking for the height of the second tallest. So what we do, we write it in ratios. The ratios here are easier to use. So the ratios are going to say that 18, the frequency of 18 is represented by 10 centimeters. How much would the second tallest, is going to be the frequency density of 10.8, how much will it be represented with? So what you're going to do, you look for the scale factor. What's the multiplier over here? How do you get the multiplier? Just do 10.8 divided by 18, and then that multiplier is going to be 0.6. That means even over here, multiply by 0.6, and then you end up your answer as 6 centimeters. That's the easiest way I can think about it. 6 centimeters using the scale factors. Thank you. We move on to the next question, part B. Part B, I'll change the color here. Okay. Part B says that how many cars were speeding between 35 and 57. 35, 57, that's part B. 35, 57. So you have 35 and 57. So we come here and look for 35. You can see when you look on this class, you look in this class of 30 to 40, we can get off numbers from 35 to 40. But this is almost half. This is in the middle. 35 is in the middle of this class. That means you just have half of this. So the estimate will be half of what? Half of 60, which is that means in that class I get out 30 cars. I go the next class. The next class has 40 to 55. 40 to 55. I have how many cars? We have 15 cars. Then we have 15 cars in that class. Now we want to go from uh, 55 to 57. 55 to 50, 57. I want to go 55 to 57. I'm looking for only 2 units. What I'm looking for, I'm looking for only 2 units out of this class size, which is 55 to 75, which is 15 out of 15. But how many cars are there in that class? There are 6 cars. So this is the fraction. Out of the six cars, I'm looking for the fraction of 2/5. So when you press a calculator for 2/5, you're going to end up with 0.08. So your cars between 35 to 57 will be 30 plus 15 plus 0.8. This is going to be 45.8. So this you can round this to 46. That is part B. I'll erase this so that I can go to part C. All right, part C. We are being asked here to use linear interpolation. Use linear interpolation to estimate the median. Now, what you're going to think about first is the position of the median. So the position of the median, we know the median is going to be the number in the middle. So the position is going to be, we have a total of 225 divided by 2, which is going to be 112.5. So this will be the position of the median. And then you have to identify which class is the median. So you're going to get the cumulative frequency, which is going to be F4, I think even in the next part of the question. So again, the cumulative frequency, so you have 54 plus 90, we have 144. 144 plus 60, we have 204. I'll get all of it. So you have 219, and then this 225. Now, the number, which is 112.5, should be in this class here, should be in the second class. That's where we expect that number to be from the cumulative frequency. So that means the median mark is in that class between 25 to 30. So the interpolation, I'll do it over here. That means, what this means, you're going to have, we are having numbers or the speed of 25 to a speed of 30. And in the middle here, we have the median, which we don't know. This is what you're looking for. But from at 25, the cars that are speeding at 25 or less than 25, they are 54 cars. And by the time you add up all the cars, the cars are speeding at 30, so the cars speeding less than 30, that's the total over here, 145. And then over here in the middle, we are looking for the position of the car that is 112.5. That's how I set up my linear interpolation. Now, how to understand this? I will not use the formula. I just want to use understanding here. So, if I use my understanding, just the last number we checked, the last time we checked on 25, we had only 54 cars. So that's our last number we have, 25. Now, out of the 25, we have 50 cars. From the 54 cars, we want to reach a number which is 112. How many more cars do we need? We need 112.5 minus 54. But in that class, we have how many cars in the class? We have how many cars in this class? In this class, we have 90 cars. But the size of the class is only 5. So this is the fraction that we are looking for, the fraction of the units we are looking for. I have set up my linear interpolation like that. So we have our starting point 25. How many cars are looking for? 112 minus 54, the one we started with at the start of the class, over 90 cars in the class. That will give you the fraction, that fraction out of the 5 units. So how much, so the question here we are answering in this part here, how much of the 5 units contain the difference that I'm looking for of the cars? Then we can press this on the calculator. So we end up with 25 plus 3.225. So your median is 28.25. Now, if you set up this line, you can use any kind of ratios. You can use ratios. You always come up with the answer. I prefer doing it like this. Okay. Then we go to the next part. Part D, we have the lower quartile Q1. They've told us that Q1 is equal to 25.14. Now they want us to find the upper quartile and then the interquartile range. Now we know that what's the position. So we're looking at part D, the first part of D. What's the position? What's the position of the upper quartile, which you can call of Q3. We know that the position of Q3 is always 3/4 of the data. So 3/4 of 225. And when you calculate this, you see that this number is 168.75. That means the position of Q3 is the number which is in the position of 168.7 position, 168.75 position. Now, then you have to add in 5 from our cumulative frequency. Which class is this? Up to this class of 30, you have added 144. Up to this class of 40, the class of 30, you have added 205. That means the culprit is this class over here. This class, the one with the Q3. Then I'll draw my line again. I draw my line again here. So at this class starts at 30 and ends at 40. At the start of the class, you have 144. At the start of the class, you have 144 cars. At the end of the class, you have 204 cars. You're looking for the number or the speed of the car that is in this position here. Remember, it is a group 2 data. You don't need to round it. You just leave the number the way it is. And that car that has that speed will be the Q3, the upper quartile mark. It's the same situation, the same scenario we used for the median. So you just have that number Q3 is going to be 30 where you started. But when you started 30, you have 144 cars, but you're looking for 168. So how many more cars do you need? 168 minus 144. These are the cars you need. Out of how many? Out of how many cars in that class? There are 60 cars in that class. Multiplied by the size of the class, you have 10 the size of the class. So you're asking yourself, this fraction of cars I need, how many units are they going to represent out of the 10? Out of the 10 units. That means you have 30. And here, these cars you're looking for 24.75. So you ask yourself, 24.75 cars out of 60, how much do they represent? You can press a calculator here and get your Q3. If you press a calculator, your Q3 will be 34.125. That's your Q3. And then we have part 2 here of you're looking for your interquartile range, which is Q3 minus Q1. So you have your 34.125 minus Q1, which is up there, 25.14. So your interquartile range, when you subtract, you have 8.985, which will be 8.999 to 3 significant figures. Okay. We go to the next part here. That is part C, the skewness of the data. I'll just make some adjustment here. Okay, this is not necessarily the skewness of the data. So the skewness of the data, we are going to look at the distance, the distances between the median, Q3 and Q1. My diagram is not correct because I don't know how it looks like. I should make something to be like, I don't know how actually it looks like. So I'll just make it like the same. So you're trying to look at the skewness. We're trying to look at the difference. So this is the median. and then this is Q3, and then this is Q1. So what you're trying to look for here, let us find the difference. Let's find the difference. The median is, where's the median? The median is 28.25. Q3 is 34.125, and then Q1 is 24, 24 or 25, not 24, 25.14. Now let us do some subtraction. So you subtract to find the distances. This is 25. Guys, you can do the subtraction. I'm just going to try the answer over here. The subtraction of the size. We're looking for this side here. We're looking for this size. What's the size over here? How many units are here? What is the size of that? And what is the size of this? So when you subtract here, you're going to find that this one is just 4.1, and then this one is 5.8. That one's 5.8. That means this is smaller. The median, which you can call Q2. It means that Q2, which is the median, minus Q1 is less than Q3 minus Q2. It means that we have a positive skewness. We have a positive skewness. That means there's more data over here in this region, and then the shape goes like that. So the tail goes on that side. So you have a positive skewness, or we have right skewness. Right skewness. All right. Now, part F says with reference comment. So R suggests a normal distribution. Of course, R is wrong because there is skewness in the data. We have just seen it in part A. That means the normal distribution is not a suitable approximation. So I cannot use a normal distribution in this data set. Thank you.